Object A of 3 kilograms moving at 8.1 meters per second bumps into the back of object B of 2 kilograms moving more slowly in the same direction at 3.3 meters per second. If the collision is completely inelastic, what are the speeds of the two objects after the collision? So this is pretty similar to the last problem, except it's completely different. And it's completely different in the fact that the collision is completely, or it's perfectly inelastic instead of perfectly elastic. So for the elastic collision, we use the formula E, which is a coefficient of restitution, equals V2 prime minus V1 prime all over V1 minus V2, both initial, equals 1. However, in this case, that whole thing equals 0. And but we don't really need to know that because I'll demonstrate something in a second. So first, data. Okay, so object A really hasn't changed much since we've last seen it. It's m1 equals 3, and we haven't really seen it, but we've seen it in our minds. So m1 equals 3 kilograms, v1 equals 8.1 kilograms. Yeah, or no, not kilograms, meters per second. What was I saying about SIs? Meters per second. And we have object 2 has a mass of 2 kilograms, or object B, right? Okay, just for those who care. Okay, let's try third time's the charm. V2 equals 3.3 meters per second. Okay, so this is all the data we need. You might be wondering why this is the case. Well, first of all, let's draw our diagram. So we have one object moving in this direction, and we have another object also moving in that direction. Different masses, different velocities. However, the velocities are in the same direction, and since it's an inelastic collision, these objects actually combine. So you have P1 plus P2 equals, and for the second part of the equation, you could write P prime. Since there's only one, you could write P1, 2 prime. I write P1, 2 prime. But for the sake of this video, let's just write P prime, because it's the only P after the collision. Okay, so now let's just do the math. And let's see how far we can get without introducing the coefficient of restitution. Spoiler alert, we don't need the coefficient of restitution. Let's see, at least I don't think so. Well, okay, technically, we can use it in the proof. How about that? Okay. Or in step 5. So here we have 3 times. Oh, actually, I'll use parentheses instead. 3 times 8.1 plus 2 times 3.3. And let's think about this. Since there's one momentum, let's think about it in a different way. Both the objects have combined, right? So what's their combined mass? It's just, we're just adding their masses together. That's how we find mass, right? So 3 plus 2, big numbers here, 3, 2, okay. And the final velocity. And I'll write V prime. Actually, I could, wait, hold on. I could have done this the whole time. Wait, I'll write V prime. Okay, so 3 times 8.1 plus 2 times, okay, let's just do the math. Wait, let's continue doing the math. Okay, so 24.3 plus 6.6. I'll just write the combined total, which is 30.9 equals 5 V prime. As you can see, all we need to do now is divide both sides by 5. So I'll just a couple of spaces here. So V prime equals 30.9 divided by 5, which equals 6.18. Again, if you care about significant figures, it's 6.2. Yeah, 6.2. However, I don't. That's our final answer. That's step 4. So actually, let me just, so this would be step 2. This over here, this thing is step 2. And everything below here, so this area is step 3. And you solve step 4. That's the answer. Okay, how about proof? Well, the proof is in, well, the phrase is the proof is in the pudding, but the proof in this case is in the restitution formula, or the formula of the coefficient of restitution. And that would be, so you have v2 prime minus v1 prime equal, or over v1 minus v2 equals 0, right? Well, the v's are the same. So 6.18 minus 6.18 over whatever that is 0. And since it's, well, we can just say the velocities aren't equal to each other. So that means it's not 0 over 0. It's just 0 over something, which equals 0. So that's one part of step 5. You could also say, what I said was, this final velocity is comparable to the initial two velocities, and it's also in between the two. Honestly, I'm actually not sure if that's necessary, the fact that 6.18 is between 8.1 and 3.3, but I presume just from a quick guess it is. So yeah, that's FRQ number 11.